Hello everyone and welcome to the 9-1 Concept Guide on tangent, arcs, and chords. First, I'd like for everybody to say hi to my daughter, Corinne. Say hi, Corinne.
Hi.
Isn't she cute? Don't make those faces, sweetheart. Okay. All right. Chapter 9 is all about circles. This first section covers most of the terms that you must know. This is a lot of terminology here in this first section. A circle is the set of all points in a plane equidistant from a given point. So if we have a circle over here, this is the circle. Of course, all of these points have the same distance from R around here, and that's the definition of a circle. The given point in the center of the circle is called the center. The distance, that the equidistant part of the definition, the distance of the segment from the center to each point on the circle is called a radius. So in this case up here, the distance from from point R to point N is called the radius. That would be radius Rn. We'll draw another one here. That's radius Rm. One more, radius Rt. All three of those segments are radii. Okay? They're equidistant. They have the same distance from the center to each of those points, so they share the same distance. A circle is named by its center, so we would call this circle over here circle R, which didn't show up right there. I'm sure it will here in a second. Let me try that again. It's called circle R, is what that is. Now, you've already seen this definition. A chord is a segment whose endpoints are in the circle. So in this circle that I've drawn over here, if I have these 3 points P, Q, and R that are on the circle, if I make segments connecting those points on the circle, there is chord PQ, here is chord QR, and here is chord PR. Those are 3 chords that connect points that are on the circle. A secant is a line that contains a chord. So a secant will go all the way through the circle. So these purple lines that I just drew, line PR and line QR, those are called chords. Those are called secants. Secants, of course, are related to chords, but a secant goes all the way through. A chord has endpoints on the circle. That is the difference between the two. One other really, really important term is a diameter. Diameter is a chord that contains the center of a circle. What'd you say? Go ahead and say it. I think my daughter knows something about a diameter. Is that right? Okay. This term can refer to a particular segment or the length of a segment. So over here in my diagram, I just drew diameter px. Here's another diameter, that's diameter QW. It goes through the center O. 2 radii equal 1 diameter. Look at the diameter that we drew right here. From WQ, WO is a diameter, OQ is a diameter. So if you put if you have a single segment, it's a diameter, it has 2 radii in it. All right, what I'd like for you to do is pause the video at this point in time and see if you can answer these 9 questions. I'm not going to show you the answer key this time. We'll talk about the answers in class. All right. Now, here are the next set of definitions. A tangent is a line in the plane of the circle that intersects the circle in exactly 1 point. I've seen that word before, tangent. Don't remember exactly where it was, though. Anyway, the point of tangency is the point. That exactly 1 point is called a point of tangency. Here's some examples. I have a circle over here. Here are 3 lines or 3 segments that touch the circle in exactly 1 point. Now, a tangent will not go through the circle. It only just barely touches the circle at a single point. So a chord cannot be a tangent. A chord goes through the circle twice, or a secant goes through the circle twice. Tangent is a very important word. We're going to be seeing a lot of that in this chapter. A sphere is a set of all points in space that's equidistant from a given point. So the difference between a circle and a sphere is a circle is two-dimensional, it's in a plane, and a sphere is three-dimensional. All right, I'd like for you to answer these 4 questions about the sphere. We're asking you to draw a diameter, a chord, a tangent, a secant. There are many, many, many ways you can answer these questions correctly, but give that a shot. Also, just see if you're paying attention. If you'll draw a little man, a little stick figure man holding that sphere, we'll call him Atlas. That'll be nice. See if you're paying attention. Pause the video, do those. Okay, we have a few more definitions here, vocabulary words that you need to know. Congruent circles are circles that have congruent radii. So if you have 2 different circles that have equal radii, then they are considered congruent. They're the same size and shape. Congruent spheres are spheres that have congruent radii. Same thing. Now, another word, concentric circles are circles in the same plane that have the same center. Now, the word con, if you remember from English prefixes, con means with, C-O-N, con. Centric means circle, so I'm sorry, it means center. So concentric means they have the same center. So, for example, a target is a very common set of concentric circles. They share the same center. Concentric spheres are spheres that have the same center. Notice that don't have as much in that definition, because concentric circles have to be in the same plane, whereas spheres, of course, don't. They're not in a plane. Now, a polygon is inscribed in a circle when each vertex of the polygon is on the circle. We have things that are inscribed in a circle, and then we have a circle is circumscribed about a polygon. That's when each vertex of the polygon is on the circle. We're talking about, well, the picture will help with this, but the 2 words are 2 phrases: inscribed in, circumscribed about. Here's an example. This red quadrilateral is inscribed in this green circle. The green circle is circumscribed about the red polygon. So it depends on if you're talking about, but the quadrilateral or the circle will determine which phrase that you use. All right, try drawing some of these yourself. Numbers 14, 15, and 16. See how that works. Sometimes helps to draw them big-ish. All right, lastly, I just want to do this example with you. Because radii are the same distance from centers to the points on the circle, when you connect chords, you end up with isosceles triangles all over the place. Because of this, we can oftentimes calculate lengths of chords and angles and things like what we did with triangles. So here's an example. Find the value of x. Let's first evaluate what we have here. There's our variable we're solving for. We have this angle in the middle that's 120 degrees. Each radius has a distance of 6. So OA has 6 OA and has a distance of 6, and so does OB. Now, we don't have a right triangle there, so we can't use the Pythagorean theorem. We do know that these angles right here must be 30 degrees, because 120 plus 30 plus 30 will get us 180. But how are we going to find x? Well, this is a trick that you're going to want to be familiar with. You'll want to draw a perpendicular segment from the center to the chord, like so. What that does is it creates a right triangle, and in this case it creates a special right triangle, a 30, 60, 90 right triangle. Over here on the right hand side we have a kind of a blown up version of what's going on inside. So we have triangle AOB with ON as a median. We have 30, 60, 90 triangle. Well, which side now is the radius? It's the hypotenuse of the 30, 60, 90 triangle. Which side of the 30, 60, 90 triangle is the altitude ON? That's the small leg. So half of the hypotenuse is the small leg. That's 3. Now, how can you calculate AN? That would be the long leg of the triangle times the square root of 3. So we end up that the length of AN, the length of NB are both 3 square root 3. Well, the question asks for what's x, which is all of AB. So we'll need to add those two pieces together. 3 square root of 3 plus 3 square root of 3 gets you 6 square root of 3, and that's your answer. You won't always be drawing that altitude, the segment which creates an altitude. Sometimes you'll just be working with, well, you might have isosceles triangles or equilateral triangles. Those are some hints that I'm trying to give you. But it will either be dealing with special right triangles, Pythagorean theorem, those, or isosceles triangles, equilateral triangles are the things that you need to be looking out for. Give these guys down here a shot, and we'll talk about them in class the next time. Have a good night. Get some rest.